Okay, we are asked to verify this trig identity that if I were to take the cosine of some angle, divide it by 1 minus the sine of that angle, that should be the same thing as if I took the secant and I added to the tangent of that angle. Okay, that's crazy that this might actually work with actual angles, but we're going to do it algebraically and verify this thing here. So this one of the strategies that we want to employ is to get rid of this 1 minus sine on the bottom. Okay, that is not a very helpful thing. That doesn't give us anything what we want. So in order to get rid of that, to be something more useful, we're going to multiply by the conjugate. Okay, and the conjugate of this thing is 1 plus sine in this case because it happens to be sine. But the conjugate always has the same terms with the opposite sign, or in this case operation. So our problem had a minus in it. The conjugate to a 1 minus is a 1 plus. Okay, so that's one of the strategies we can employ when we're trying to verify identities, is multiply by this fancy number 1. So this is a fancy number 1. The same thing on top and bottom is 1, and we are not actually changing this. We are going to manipulate it, but we're not changing it. So let's do a little bit of simplifying. On top, I have 1 plus sine times the cosine, and I know you're going to be tempted to distribute that, but just don't, because I know what we're going to happen in the end, so don't distribute it. And on the bottom, we now have 1 plus sine times 1 minus sine. Okay, so now we can, in fact, do some distributing in the denominator. So let's multiply 1 times 1 and 1 times minus sine and sine times this and all those other fantastic things. So we're doing the algebraic property of distributing. Most of these verifying identities are actually just doing algebra. And we have 1 minus the sine plus the sine minus the sine squared. That's what we get when we distribute all of that out. And now we're going to combine our like terms, and minus sign and plus sign go away. So showing every single step, this may be redundant, but we're going to do it anyway. We are left with 1 minus sine squared in your denominator. So now we're going to do the one part of the trig thing that we're going to do so far. It's all been algebra. I'm going to replace 1 minus sine squared with its Pythagorean identity, which is cosine squared. So on the denominator, I now have cosine squared, but the numerator stays the same. And hopefully you can see now why I did not want to distribute on the top. Okay, because now I can do some simplifying. One of these cosines on top cancels out with one of the cosines on bottom because I am multiplying, and you can cancel with multiplication. So after I cancel that out, now I have just 1 minus sine on top, and I have just 1 cosine left on the bottom. Okay, so now I'm going to employ a slick little number property that says if I have addition in my numerator over a single denominator, I can change this into the sum of 2 fractions. So 1 over cosine plus sine over cosine. Right? If I were going to go the opposite way and I had this fraction plus that fraction, they both have the same denominator, so I can add the numerators. Well, if it's convenient, I can split that up and do the exact opposite. Okay, and here it's going to be convenient to do that, because now I'm going to do 2 more substitutions. 1 over cosine is also known as the secant, and sine over cosine is also known as the tangent. Now looking back way up here now, I can see that that is exactly what I wanted it to equal. So by multiplying by this fancy number 1, okay, called the conjugate of my denominator, and employing some algebra strategies and a couple of substitutions, I am able to verify that that does in fact equal secant of the angle plus the tangent of the angle.